Over the last 70 years of spaceflight, one thing has been constant. What man puts into orbit, they seldom clean up. It is estimated that there are 34,000 pieces of debris, 10 centimeters and larger, in orbit. Each one is traveling at roughly 8 kilometers a second, a field of flak waiting to strike passing spacecraft. A small 1.2 centimeter diameter sphere of aluminum, traveling at nearly 7 kilometers a second and weighing less than 2 grams, hits a block of aluminum 18 centimeters thick. The result is catastrophic.
The space debris problem goes hand in hand with space exploration in general. We are constantly putting satellites and craft into orbit, and some portion of those craft will become defunct. As orbits become more crowded, the chance for collisions increases, and along with that increase is the chance for craft to become inoperable and out of control. Dead craft can stay in orbit for hundreds of years, and as space becomes more crowded, the chances these dead craft hit other orbiting craft increases. Already, there are more than 128 million pieces of debris that are less than 1 centimeter, and they can leave holes like we previously saw. These impacts can then turn 2 pieces of debris into thousands. This potential cascade of debris is better known as Kessler Syndrome. A potential candidate for causing Kessler Syndrome is the European Space Agency's Envisat satellite. It went offline in 2012, and it weighs approximately 8,200 kilograms. It comes within 200 meters of 2 cataloged objects each year. There are some solutions to this problem. The Japanese Aerospace Exploration Agency has undertaken tests of its spacenet that, while so far unsuccessful, do pose some promise. Additionally, ground-based lasers have been proposed in order to burn up smaller pieces of space debris and impart just enough thrust to deorbit the larger pieces. Mitigation is also a possibility. The United States government currently requires each satellite launch to have a plan for its disposal through means such as atmospheric reentry or movement to a graveyard orbit. Some have said that space is the final frontier. Whatever it may be, it is a vitally important resource for humanity. It holds promise for a bright future where we can take advantage of new resources and further our understanding of Earth by continued operation of satellites in low Earth orbit. By reducing debris, we keep that promise open, not just for ourselves, but for future generations.